Hey, my name is Raivo Sell, and I'm working at TalTech Autonomous Vehicles Research Group Leader. I'm going to give you a short overview about our research group activities connected to the smart cities, and also some experiments and pilots what we did this year here in Tallinn. The main focus what our research group is doing is focus to the autonomous vehicles technology. We have designed and developed in cooperation with Estonian company Iseauto, which is a small robot bus fitting up to the 6 persons, and it's designed as a last mile shuttle bus in level 4. So it's fully autonomous. There is no steering wheel, no brakes and throttle. So this vehicle we are using mostly now for the experiments, and we have 2 vehicles which are connected in different smart city communication and cybersecurity experiments. So our expertise and focus right now is V2X communication between the vehicles over the 5G human-machine interface. We do the simulations and verification and validations to improve the safety of AV technology. We also do the small mobile robotics developments and connected to smart city. Right now our focus is the teleoperation and different infrastructure connections. So the main collaboration what we have very tight cooperation is mostly from US, the Florida, different universities there like Florida Bolu and Embry-Riddle University in Orlando, but also in the South Carolina and Japanese universities. For example, we are and members of Autoware Foundation, which is initially from Japan and is open source autonomous driving software. We also recently joined with the International Alliance of Mobility Testing and Standardization Organization. So more information can be found on our website, and everyone is welcome to explore it. So we have the concept here in our campus to make a scaled model of smart city, and it's constantly developing, but currently we have a 5G network up and running. We have our AV shuttles driving there for the experiments. We have a smart traffic signs and working with a smart and adaptive traffic lights which supplying the experiments for V2X and V2I. Also in our campus there are small Starship package robots driving around, and there is a zero energy building and different innovations which forms together a very nice environment for experimenting the new feature of a smart city. For example, some experiments we did last year in combination of vehicle-to-vehicle communication, that how the vehicles driving on the road are communicating with the small robots who are driving in pedestrian ways. So over the 5G, for example, they can already communicate how to adjust the speeds and how those intersections can be solved in a safe way, that there is no waiting time. It's also connected to the energy efficiency and energy saving. Another maybe important functions what we're working right now in cooperation with a German spin-off from TU Munich, a company called Pilot, is a teleoperation. So as a vehicles getting smarter and at some point we need to remove also the safety person, they still need a human supervision. And it goes now over the network, so one remote driver can actually supervise and drive not just one, but up to 10 different vehicles. So in most time they are autonomous, but if there is some complex situation, then the remote driver then get over the driving functions. But of course, it's connected very much to the cybersecurity, and it's very important that all systems function very safely. It's also connected with the data, so we are logging driving parameters, we are storing the video point clouds, so it's a massive data is actually stored for every second from the vehicle. And it includes also the situation awareness and what things going on inside the vehicle. For example, we are detecting the violent behavior and so on. So also some experiments are publicly available in our YouTube channel. The cybersecurity, as already mentioned, is now our focus and also it's connected to the safety assessment and verification and validation technologies. So it's the aim is actually to develop the toolkit for the cities who wants to implement the pilot, self-driving vehicle pilot, but they don't really know what are the threats in terms of safety and cybersecurity, of course, and also what is necessary to do to, let's say, make a call for technology providers. So in this toolkit, we offer the nice process for the cities, how to really go through this process and do the risk assessment and analysis. So it includes also virtualization, mapping, and simulations. So two pilots we had this year. First was in Tallinn Ülemiste. The route was about 2 kilometers, and in total we drive 2,500 kilometers. So we actually tried to investigate integration with the city transportation system, fleet management, remote control and monitoring. We had a smart bus stops over there, but also how people were thinking about these new technologies. So we had a free buses plus backup bus on this route, and this experiments last 50 days during July and August. And in the end, it was quite successful. People really liked this, but also we got valuable lessons at what's not maybe working that well and what needs to improvement. As for example, testing and verification is needs to be formalized. The safety simulations are more needed, and also legal environment is not yet that supportive for AV technologies. So there are different things. And what I really want to point out is the collaboration between the different parties. For example, like we had in this case, university, private companies, local authorities, and so on. So the collaboration is actually very important. And the second pilot we had this summer was with the Navia, probably the most well-known AV vehicle or the last mile vehicle at the moment. It's a French company, and there we have a round route in one leisure park in the center of Tallinn, and it was serving people from tram stop up to the art museum. It was very popular, and also we were testing there how those technology works, how the service robustness is provided, and also we were comparing with other cities, because in the same time the similar experiment were in Helsinki, in Norway, and Poland. So we got quite nice data out of this. And also the lessons learned that this it's very important, specifically with the cities who are planning these pilots, that how to really prepare the road, what kind of traffic adjustments needs to be done, how the drivers are interacting with the self-driving vehicles. They are not maybe always following the traffic laws, and how those things can happen. So it was also quite good experiments. And right now we start a new experiment in Lamia, Greece, and also here in Tallinn in our campus. So our plans are now for mostly focused to the new pilots in our campus, focus on remote control, cybersecurity and things, new pilot cases, and the toolkit for the cities, what just explained about road mapping, virtualization, simulations, defining the corner cases, testing the corner cases in a dedicated test bed, also V2X and cybersecurity tests, safety and risk assessment, and recommendation for implement the pilot. So we have the methodology right now under development, and I hope we can help the cities pretty soon how to implement this. And that's pretty much it. Here is also a little overview about our smart campus concept. And thank you very much. I hope I'm also able to answer questions.